Imagine ancient builders meticulously stacking mud bricks in bitumen mortar, constructing monumental ziggurats, these towering testaments to human ingenuity and, let's face it, arduous, painstaking labor.
Generations of work, countless hands.
Exactly, an unwavering commitment to precision. Now, fast forward with me to today. Picture a modern construction site. It's no longer just humans with shovels, hammers, measuring tapes.
Not entirely.
Right. Increasingly, you're seeing sophisticated machines. We're really on the cusp of a profound transformation, moving beyond that, romanticized past into an age where robots are becoming integral, indispensable almost, to building our future.
And that shift is exactly what we're going to unravel today.
Yeah.
Yeah, we're diving deep into the real-world applications of robotics on the job site. We're trying to move beyond the sci-fi hype.
Get past headlines.
Exactly. And really digging into how automation is being leveraged right now to tackle tasks that are traditionally dangerous, incredibly repetitive, and just physically demanding for human workers.
The 3Ds. Dull, dirty, dangerous.
That's them. Our mission here is to unpack the whole spectrum of these emerging technologies. We're talking everything from advanced bricklaying bots that can work around the clock, like tireless precision,
Wow.
to massive autonomous vehicles doing complex excavation. We'll also need to clarify that crucial distinction between robots that augment human workers, making them safer, more productive, and those that are designed to fully automate specific tasks.
Okay, augmentation versus full automation.
Right. And yes, we'll definitely confront the significant barriers, things holding this back.
Because it's not all smooth sailing.
Not at all. High initial costs, obviously. And the inherent unpredictability of a dynamic construction environment. It's messy out there.
It really is. Ultimately, we're going to delve into the long-term impact of all this on you, the human workforce.
Yeah.
Will robots take jobs? Is it mass displacement? Or will they create new, maybe higher skilled opportunities, fundamentally transforming what it means to build? This isn't just speculation. We want this to be a realistic, grounded look at a technology that promises to redefine safety, productivity, quality, the whole lot, really.
Yeah. It's giving us a fascinating glimpse into those collaborative teams of the future, humans and robots, actually building together.
And where are we drawing this from? What's the background material?
Well, to give you this comprehensive understanding, we've drawn from a pretty rich stack of sources.
Yeah.
We've got authoritative industry guides like the CMAA Construction Management Standards of Practice, the PMBOK Guide, Project Management Essentials.
Standard stuff for the pros.
Exactly. Plus the BIM Handbook for the digital modeling side. We also looked at historical architectural texts, detailed construction manuals like Building Construction Illustrated, the Builder's Guide to Hot, Dry, and Mixed Dry Climates.
Practical guides.
Very practical.
Mm-hmm.
And critical analyses of engineering and technological impact, things like designing reality and the goal. So we're trying to cover both the nuts and bolts and the bigger picture implications.
Okay. Sounds comprehensive. Let's dive in.
Yeah.
So to really grasp this seismic shift we're seeing, maybe let's zoom out for a sec. We've lived through the first digital revolution, communication analog phones to the internet, massive change.
Huge.
And the second in computation PCs, smartphones. They fundamentally changed the world, right? Like the book Designing Reality points out. But now we're apparently in the midst of a third personal fabrication, blurring the lines between digital design and physical creation.
Mm-hmm.
So how does this broader societal wave, this third revolution, how does it crash onto the shores of construction? An industry often seen as, well, a bit traditional.
That's what's so fascinating. Construction has traditionally been one of the last major industries to fully embrace automation on a really large scale.
Lagging behind manufacturing, for instance.
Absolutely.
Absolutely.
But as you say, it's now poised for rapid, maybe even transformative change.
Right.
If we look back historically, even the most monumental projects, think the Great Altar of Pergamon in ancient Greece, stunning marble structure, or Nero's Golden House in Rome, this vast opulent palace.
Incredible feats.
Incredible feats, yes, but fundamentally achieved through sheer human organization, immense manual labor, and relatively simple tools. Even something like the Great Ziggurat of Ur-Nammu, way back around 2000 BC, a massive terrace structure, mud brick core, baked brick facing, and bitumen mortar.
Just stacking.
Just stacking. An arduous manual process relying solely on human strength, human coordination, generations of effort.
And even later, when we saw early industrial automation.
Yeah, like the really precise setup of printing presses detailed in Moxon's 17th century mechanic exercises. But that was a highly structured, highly controlled environment.
Nothing like a construction site.
Nothing like it. A far cry from the dynamic, unpredictable chaos of a typical job site. Even the simple pulleys and winches on scaffolding used by medieval cathedral builders.
Basic machines.
Basic machines, yeah.
Yeah.
They showed the intent for efficiency was always there, that human desire. But the tools themselves remained pretty basic. Now, though, we possess technologies capable of navigating that complexity, performing tasks with an intelligence and endurance that was just unimaginable a few decades ago.
It's a convergence, then. Necessity meeting capability.
I think that's a great way to put it. A convergence of necessity and capability.
So, given that history of immense human effort, what are the enduring problems in construction today that make robotics so compelling? What's driving this push now?
Well, the immediate and probably most significant benefits lie in tackling what the industry calls the dull, dirty, and dangerous aspects.
Right.
Safety is, without question, paramount. Just think about the daily risks workers face. Falls from height, injuries from heavy machinery, exposure to hazardous materials.
The list goes on.
It really does. Robotics can remove humans entirely from some of these inherently risky tasks, directly expanding the safe zone, as lean construction safety practices talk about.
So it's not just about fewer minor injuries.
Oh no, it's about preventing catastrophic incidents. The kind tracked in meticulous safety programs, scrutinized for OSHA compliance. By deploying robots in hazardous environments, think demolition, working at extreme heights, handling toxic materials, we can dramatically decrease human exposure. It's moving towards a much safer, frankly more humane industry standard.
Okay, safety is a huge driver. But beyond the immediate danger, what about the sheer monotony? Tasks that aren't necessarily life-threatening but are just grinding, can that lead to problems too?
Absolutely. That's where robotics also shines brightly. Many construction processes involve highly repetitive motions. Think about applying caulk or glue or gasket in drywall finishing. It's precise, yes, but it's an endless uniform action.
Mind-numbing after a while.
Exactly. And human fatigue, even among highly skilled workers, inevitably leads to errors, inconsistencies, decreased productivity over a shift, over a week.
Yeah, you can see that.
Automation, on the other hand, offers tireless consistency. Precision. Robots don't get tired, they don't lose focus. They can maintain a level of accuracy that human workers simply cannot sustain over extended periods. So it directly addresses those monotonous, repetitive tasks. You get higher quality output, longer durations, and it frees up human workers for more complex, less physically draining roles.
So mitigating risks, increasing consistency. Does this translate directly to better project outcomes, better timelines, better budgets? Or is it, again, more complicated?
The ultimate goal is definitely to enhance project delivery across the board. But it's not always a simple straight line. When implemented effectively, yes, it means improving key project metrics, things like schedule variance, SV, are we ahead or behind schedule, and the Schedule Performance Index, SPI, how efficiently are we working, both critical indicators from the PMBOK guide.
Industry standard metrics?
Right. Robotics can definitely bolster that workflow reliability that lean construction principles like the last planner system aim for, making sure tasks are, well-defined, sound, sequenced, and sized to performer capabilities. It leads to a more predictable, streamlined process.
But I sense a but coming.
There's always a but, isn't there? This raises that important question from Eliyahu Goldratt's book, The Goal. Achieving local efficiencies, making one step super fast with a robot, doesn't automatically translate to increased overall project throughput or reduced operating expenses if bottlenecks elsewhere aren't addressed.
Right, the theory of constraints.
Exactly. A robot might lay bricks incredibly fast, fantastic. But if the materials aren't supplied at that same accelerated rate, or if the next trade isn't ready to follow immediately,
The robot just waits.
the robot waits, and the overall project doesn't necessarily accelerate. So while the potential for financial and schedule benefits is enormous, it absolutely requires a holistic view. You need to manage productivity across the whole system, optimize the entire flow, not just tweak individual parts.
That's a crucial point, the whole system view. But let's bring it back down to the ground level again. Let's visualize this. What specific tasks, the ones that are often dangerous or really difficult for humans, are robots actually doing now? Tackling that dirty and dangerous stuff.
Okay, yeah. We're seeing robots taking on a growing range of these demanding roles. Think about large-scale excavation and grading.
Big earth moving.
Huge earth moving.
Yeah.
Often involves massive, heavy machinery, navigating tricky, sometimes unstable terrain. Visibility can be poor, accidents can be devastating. Now, autonomous vehicles are stepping into these roles.
Like self-driving dump trucks.
Sort of, yeah, and excavators, graders, performing earth moving, site prep with precision, GPS guidance, and significantly reducing human exposure to accidents on the ground. Fewer operators in the direct line of fire from, say, falling debris or unexpected ground shifts.
Makes sense. What about working at height? Always risky.
Definitely. Take tasks like tying rebar on a high-rise. Traditionally, workers are up there, sometimes precariously balanced.
Yeah, I've seen that. It looks terrifying.
It can be. Now, drones are being developed, and in some cases deployed, to perform these precise, repetitive movements, carefully bending, tying, steel, reinforcing bars. This not only improves safety, keeps humans on solid ground, but also boosts speed and consistency.
Wow, rebar tying drones.
And even handling incredibly heavy components, like lifting and positioning large steel channel sections for stair stringers or massive precast concrete treads. Tasks that traditionally need multiple workers carry significant ergonomic risks.
Back injuries waiting to happen.
Exactly. These could be greatly assisted or even fully automated by robotic systems, robotic arms. It just makes the job safer, more efficient, and way less physically grueling.
Okay, so that's the dangerous stuff. But where does that robotic consistency and precision really come into its own? Tasks where unwavering accuracy makes a huge difference, maybe in quality or long-term building performance.
Right, the consistency factor.
Yeah.
It truly shines in repetitive, high-volume tasks where precision is absolutely paramount and where human variability, even slight inconsistencies, can lead to significant issues down the line. Let's look at a few striking examples.
Okay.
First, bricklaying robots. These are often the poster children for construction robotics, right?
You see the videos.
They can work continuously, like 247 if needed, laying bricks with a consistency, a precision that human masons, even the most skilled ones, simply cannot match over long shifts.
Tireless.
Tireless. And this is especially useful for projects demanding really exacting standards. Say, using premium FBX face brick, that category known for its uniform size, narrow color range, high mechanical perfection. Building Construction Illustrated talks about this.
Yeah.
Ancient ziggurats showed incredible human dedication to precision, but it was incredibly labor-intensive, limited in scale.
One monument at a time.
Right. Robotics shifts this. It lets us replicate that dedication to perfection, potentially across entire urban landscapes. It frees designers from some traditional constraints of human physical capacity. It's not just faster, it might enable a whole new architectural grammar. These robots ensure near-perfect alignment, consistent mortar joints, precise spacing every single time, reduces rework, enhances structural integrity, improves the aesthetic quality.
Okay, bricklaying. What else?
Then there's automated drywall finishing. Think about the detailed process of sealing and finishing interior surfaces. Taping, sealing drywall to wall drywall, caulking, gluing, gasketing drywall to top and bottom plates.
Fiddly work.
Very fiddly, incredibly time-consuming, and highly prone to human variability. A slightly uneven application of joint compound, a wrinkle in the tape. It can lead to aesthetic flaws, sure, but more critically, it can compromise the building's performance.
Air leakage.
Exactly. Air barrier continuity. Robotic systems can ensure a perfectly consistent application of compound and tape. That consistency is vital for energy efficiency, indoor air quality, especially in those challenging climates the Builder's Guide talks about. They perform these critical sealing actions with unwavering accuracy, something very tough to sustain manually over large areas.
Right, consistency is key there. Anything else?
One more big one. Robotic interior layout systems. Instead of manual measurements, chalk lines, and the potential for human error accumulating across a large space.
Where one small mistake early on gets magnified.
Precisely. Robots can project or mark precise interior layouts directly onto floors, walls, ceilings using lasers or printers. This ensures perfect alignment for everything: walls, partitions, MEP systems, fixture placements. This level of precision is absolutely critical for meeting strict dimension requirements, like concrete filling between beams where clear space is essential, as detailed in the Kidder Parker Handbook. The accuracy here minimizes rework later, ensures the highest quality from the start, saves time, saves materials.
Okay, those are incredibly precise applications. So, thinking back to our earlier point, are we talking full replacement here? Robots taking over these jobs completely? Or is it more that partnership model? What's the range?
It's definitely that spectrum again. Both models exist. Some technologies, like maybe those specialized bricklaying robots, are aiming for full automation of a very specific, well-defined task. Their goal is to take it over entirely. Speed, consistency, doing one thing incredibly well, repeatedly.
Optimized for that task.
Exactly. But many, perhaps even most, other applications are designed to augment human capabilities, not replace them. Think of that robotic arm precisely lifting and positioning heavy wood studs like building construction illustrated mentions.
The heavy lifting.
Right. It does the heavy lifting, the precise placement, allowing a human carpenter to then do the final, maybe more nuanced fastening, safer, more accurately. It's an evolution from power tools, like those self-drilling screw guns, but with much greater intelligence and capacity. The robot provides the strength and precision. The human provides dexterity, judgment, adaptability for the final critical steps.
So it boosts the human, doesn't sideline them.
That's the idea in the augmentation model.
Okay, so in that model, humans shift away from the brute force, the repetitive strain, and become more about the oversight, the problem solving, like conductors.
Exactly that. A great analogy. The overarching goal is often to free humans from the ergonomically challenging, the highly repetitive, or the inherently dangerous parts of the job. This lets workers pivot their focus to higher value activities, complex problem solving on the fly, real-time quality control, adapting to unforeseen site conditions, something robots still struggle with, managing the more nuanced adaptive aspects in that unstructured environment.
So it elevates the human role.
It fundamentally shifts the nature of the human role on site towards more cognitive, supervisory, strategic functions. It fosters that collaborative team where humans and robots play complementary parts, leveraging the unique strengths of each. It's about symbiosis.
It makes total sense that these complex machines need detailed guidance. They can't just wander around a chaotic job site and figure things out, right? So how exactly do they know what to do, where to go? What's the core connection between the digital plans and the physical robots doing the work?
The fundamental connection, the language and the map for these construction robots, is building information modeling, BIM.
BIM! We hear that term a lot.
We do. And as texts like the CMA standards and the BIM handbook make clear, BIM isn't just fancy software for making cool 3D drawings. It's a whole process for capturing, analyzing, documenting, iteratively revising digital representations of a facility's physical and functional characteristics throughout its entire life cycle.
So it's the data behind the model.
It's the data, the relationships, the whole digital twin concept, essentially. For a robot, BIM acts as its precise instruction manual, its navigation system, its real-time quality control checklist, its communication hub, all rolled into one integrated data environment. It gives the robot the exact spatial and contextual info it needs to execute tasks with that precision we talked about.
So the digital model isn't just for designers and architects anymore. It's become absolutely essential for the machines themselves to function.
Absolutely essential. That paradigm shift from drawing to modeling,
Yeah.
as the BIM handbook puts it, is crucial for automation. Think of BIM as the robot's ultimate instruction manual, but interactive, incredibly detailed. It provides object classification, telling the robot, this is a wall, this is a pipe, this is a window.
Giving things labels.
Labels, yeah. Naming conventions, attribute structures, specific properties for each component, and crucially, designation of topological interfaces. That tells the robot exactly how each piece connects to others. Its digital handshake with its neighbor.
How things fit together.
Exactly. This granular data lets robots understand not just where they are, but what they're interacting with, what its properties are, and how to precisely build or manipulate it. It's kind of like how ancient architects, like Palladio in his 4 books of architecture, would meticulously detail column proportions and intercolumniations. BIM offers that same level of meticulous detail, but in a dynamic, machine-readable format.
Guiding the autonomous process.
Precisely, with unparalleled accuracy.
Okay, that makes sense. So what are some of the key BIM features that really make this integration with robotics possible? What makes it indispensable on site?
Right. Several specific features within BIM are really indispensable for integrating and optimizing robotic workflows.
Okay.
Firstly, 3D parametric modeling. This gives the robots the precise geometric data they absolutely need, whether it's placing masonry veneer, framing structures like in building construction illustrated. Parametric models let robots understand the exact dimensions, shapes, relationships.
And parametric mean?
It means the elements have relationships. If you change the height of a wall, the associated windows and doors might adjust automatically. Crucially, these models can be adjusted in real time. If there's an unexpected site condition, a slight design tweak, the model updates, and that immediately informs the robot's next actions. Vital for managing that dynamic construction environment. Without that flexibility, robots would be too rigid.
Got it. What else?
Secondly, clash detection. This is huge. Before any physical work starts, BIM allows for virtual hard-at reviews, clash detection exercises. The CMAA standards highlight this. It identifies physical conflicts, spatial constraints, helps coordinate disciplines.
Finding problems before they happen.
Exactly. Imagine a robot installing ductwork only to find a structural beam or a pipe unexpectedly in its path. Bang. Halt operation, cause damage, errors. Clash detection finds those issues virtually by overlaying different building systems, structural, mechanical, electrical in the model. It ensures a clear path, optimal placement for robotic work, preventing costly rework.
A critical preemptive step.
Absolutely critical. Thirdly, 4D schedules.
4D, so time.
Time is the fourth dimension, exactly. Adding time to the 3D model creates 4D schedules. It visually represents the entire construction sequence, means, methods, logistics, a simulated construction timeline. For autonomous robots, this gives essential temporal context, when and in what order tasks should happen. It allows for a coordinated choreography of human and machine activity. Minimize idle time, prevent clashes between trades, maximize workflow efficiency. The robot knows what to do and precisely when.
Okay, 3D, geometry, clashes, time. Anything else?
Lastly, quantity takeoff and model-based estimating. BIM can automatically generate highly accurate material quantities directly from the model. This data feeds straight into cost control budgeting, as the CMAA standards note.
Better estimating.
Much better. And when robots are involved, this precision can lead to highly optimized material use, significantly reducing waste, a major environmental and financial win. It also provides concrete data for informing contract sum adjustments, as mentioned in project management and construction. It gives a real-time, data-driven understanding of material use and costs. All these features together create that digital environment where robots can operate efficiently, accurately, backed by reliable data.
Okay, but with all this digital data flowing, especially when machines are making physical decisions based on it, how do you ensure it's reliable? Trustworthy. Data integrity must be absolutely paramount, right?
Paramount is the word, absolutely. Particularly when autonomous systems are making physical movements, structural decisions. For robots, reliable sensor data and accurate model information are non-negotiable. Edward Tufts' work, like the visual display of quantitative information, emphasizes this. For any data, it must be clear, accurate, not quoted out of context.
Garbage in, garbage out.
Exactly, but with potentially much bigger, more physical consequences. Any distortion, ambiguity, error in the data can lead to significant errors in robotic execution. Structural flaws, safety hazards, major rework.
So how do you manage that?
This is where the human element, specifically the construction manager, often steps in as that crucial central information hub. The CM is responsible for establishing, maintaining document control protocols, ensuring the entire project team is educated on BIM's benefits, but also its limitations and the absolute need for data accuracy. This holistic management of information, this oversight, is what makes it possible for robots to operate effectively, reliably. Without meticulous data integrity, the GI-GO principle applies, but potentially with much more expensive and dangerous results.
Okay, these advanced robotics sound incredibly impressive. Huge leaps in safety, precision, but they also sound incredibly expensive. Is that initial investment the biggest barrier? Is cost the main reason we're not seeing them everywhere already?
High capital cost is, without a doubt, a significant barrier, a major hurdle, especially for an industry like construction, often known for its relatively thin profit margins.
Tight budgets.
Very tight. Investing in robotic systems typically involves substantial upfront expenditure. Not just the hardware, the robots themselves, but also the specialized software, the complex integration into existing workflows, and the necessary training for the people who will operate and maintain them.
It's a whole package deal.
It is. And this directly impacts the project financials, influences everything from the cost of labor, fringe benefits, materials, supplies, equipment, even bonds, insurance premiums, fees and contract sums, as project management and construction details. For many contractors, especially smaller and medium-sized firms, that initial outlay can just be prohibitive, a major deterrent.
So how do you even begin to justify such a big investment, especially if the returns aren't immediate or obvious? How do you build that business case?
Yeah, justifying it requires a robust, often long-term business case. It's actually quite similar to the detailed cost analysis done for high-performance green buildings.
Like LED certification.
Exactly. Light and UNSI certifications might initially show cost premiums, maybe 0.66% up to 6.5%, right? But those are typically offset by significant long-term benefits. Energy savings, water efficiency, better occupant health, productivity, lower operations costs over the building's life. as Sustainable Construction Green Building Design and Delivery points out.
So you look at the whole life cycle cost.
You have to. Robotics needs to demonstrate similar long-term value. Dramatic, quantifiable improvements in safety records. Consistent quality that significantly cuts down rework and material waste. Accelerated project schedules leading to earlier revenue or handover, reducing overall project duration. The argument have to shift from simple upfront cost to total cost of ownership, lifetime value proposition.
But proving that takes time and data.
It does. Without clear, compelling evidence, often needing data from pilot projects overcoming that initial capital cost hurdle, remains a really formidable challenge for widespread adoption across the industry.
Okay, cost is big. But you mentioned the environment earlier. A factory floor is controlled, predictable. Robots love that. A construction site is not that. It's constantly changing, exposed to weather, inherently unpredictable. I mean, even building flat pack furniture can go wrong if one piece is slightly warped. How do robots handle that messy, dynamic reality on a massive scale?
Your bookshelf analogy is perfect. And it brings us to arguably the most formidable technical challenge for construction robotics. Construction sites are inherently unstructured, non-standardized environments, constant variables.
Chaos, basically.
Controlled chaos, maybe, sometimes. But think about it. Changing weather, rain, wind, heat, cold. Remember Washington's retreat from Long Island in 1776?
Yeah.
Delayed by wind and tide? Unpredictable external factors can totally upend plans.
Nature gets a vote.
It always does. On site today, you've got shifting soil conditions needing constant analysis and adaptation, unpredictable material placement by other crews, dynamic human activity all happening simultaneously. Robots, traditionally engineered for predictable factory tasks, struggle significantly with this variability, this uncertainty.
So a small change throws them off, like an unexpected pallet or a puddle.
It absolutely can.
Yeah.
A misplaced stack of bricks, a slight change in ground elevation, a sudden puddle from rain. It could halt an autonomous robot or worse, cause errors. So overcoming this requires incredibly advanced sensing, LiDAR cameras, radar working together for real-time mapping, localization.
Seeing and understanding the environment.
Exactly. Plus sophisticated AI for decision-making under uncertainty. Robust error recovery. What does it do when something goes wrong? Can it fix it or call for help? These are all still areas of very active research and development. Requires massive computational power, refined algorithms, the current difficulty even in mastering digital fabrication workflows, leading to that high priest class of creators mentioned in Designing Reality. It hints at the immense complexity of deploying these systems reliably in truly unstructured environments. It's not trivial.
Definitely not. So beyond the technical and financial hurdles, are there also sort of human and bureaucratic obstacles slowing things down? Because it's not just about the machines, is it? It's the whole ecosystem.
Yes, absolutely. The integration introduces several layers of regulatory, cultural, managerial complexities. Just as challenging, maybe even more so than the technical stuff.
Like what?
Okay, first, regulatory frameworks. Existing building codes, permitting processes, quality assurance. They're all meticulously crafted around traditional human-led construction methods. Known risks.
They know how people build things.
All right, now imagine introducing a fleet of drones to autonomously inspect a facade or a robotic arm installing structural components. Regulators might demand entirely new certifications, exhaustive testing, liability frameworks that just don't exist yet or are very immature. How Buildings Learn talks about how slow it can be to update regulations for genuinely novel approaches. This isn't just paperwork delay. It can mean years of pilot programs, lobbying, data collection before a new robotic method gets widespread approval. A huge bottleneck for innovation.
Bureaucracy meets technology.
Pretty much. Second, that thorny issue of risk allocation and liability. If a robotic bricklayer messes up a wall, causes a structural issue, or an autonomous excavator malfunctions, causes an accident, injury, who's legally responsible?
Good question. Manufacturer, software dev, site manager, the company leasing it.
Exactly. Our current construction contracts, with their complex clauses on perils of nature or contractor negligence, as construction law details, they just aren't equipped for this entirely new category of risk. This legal and insurance uncertainty creates significant reluctance for companies to adopt technologies where accountability is blurred.
Makes sense. People are wary.
They are. Third, we face human resistance and trust. There's natural skepticism, sometimes outright resistance, to new tech, especially if it's seen as threatening jobs. If workers or managers don't trust their project team members, project manager, or the organization, a critical element of collaboration in the PMBOK guide, They're far less likely to embrace changes brought by
A
robots.
fear factor.
Fear factor, yeah. The potential for job displacement fosters resistance, makes transparent communication and reporting about risks and opportunities crucial, as project risk management in the CMA standards outlines. Without buy-in from the people on the ground, even the best robot struggles.
And
Finally, integration into project management itself is a huge challenge. Just buying robots isn't enough. The entire project management process needs to adapt. From conceptual design, constructability reviews, procurement strategies, quality management, everything. It demands a significant shift from purely predictive sequential processes to maybe a more adaptive, agile approach, especially when requirements are uncertain, volatile, or complex, as the PMBOK guide suggests. Project managers need to become adept at managing these hybrid teams of humans and machines, leveraging new data streams, orchestrating complex robotic workflows. It's a substantial managerial and cultural transformation.
okay, this brings us right to the million-dollar question, doesn't it? The one on everyone's mind. What does this mean for the human workforce? Are robots going to take all the construction jobs? Is it widespread displacement? Or is the picture maybe a bit more nuanced than that?
I really think the historical pattern with major technological shifts suggests job transformation rather than outright elimination. And I believe construction will likely follow that suit. In the goal, when the plant installed robots, the employees were actually shifted to other jobs within the company, not laid off.
Retrained, repurposed.
Exactly. It indicates that new roles, new functions were created within that evolving system. So this suggests that while certain roles, particularly those involving the dangerous, dirty, or highly repetitive tasks we discussed, might well be fully automated, new types of jobs will undoubtedly emerge in construction. It feels much more like an evolution of the workforce, not an extinction of human involvement.
So the roles aren't vanishing, they're just shifting significantly. Fewer people physically laying bricks, maybe, but a whole new group of specialists needed to manage the machines themselves.
That's precisely the transformation we're beginning to see. The industry is already experiencing a shift towards demanding higher skilled ones. We're talking about roles like robot operators, people overseeing multiple machines, ensuring they function correctly. Programmers who adapt robotic systems to specific project needs, troubleshoot software.
The tech support for robots.
Kinda, yeah. Maintenance specialists, ensuring these complex machines run efficiently, safely, doing repairs. And of course, data analysts interpreting the vast amounts of information these systems generate to optimize performance, inform future decisions. It also includes those integrated automation specialists, categorized in master format divisions, who are experts in blending different automated systems into a cohesive whole. These are sophisticated roles needing a different, often more cognitive and technical skill set than traditional manual labor.
That's a fascinating glimpse at the new roles. But what about the existing workforce and people coming into the industry? What kind of new skills will they need to thrive in this evolving human-robot environment? How do people adapt?
The emphasis for the future construction worker, existing or new, will unequivocally move away from pure manual dexterity toward a suite of cognitive, analytical, and interpersonal skills. Workers will need strong digital literacy, being comfortable interacting with robotic systems, BIM platforms.
Comfortable with the tech.
Definitely.
Yeah.
They'll need sophisticated problem-solving abilities to troubleshoot unexpected issues on the fly, things robots aren't good at yet. A foundational understanding of how robotic systems operate. It actually resonates with Frank Lloyd Wright's critique of rote learning and standardized practices. He advocated for independent thought, creativity, a deeper understanding of principles.
Thinking, not just doing.
Exactly. The future construction professional will be less of a manual laborer doing repetitive actions and more of a digital craftsman or a systems integrator. Someone capable of understanding and managing the entire technological and human ecosystem of a project. Orchestrators, not just single instrument players.
So it's about seeing the whole picture, understanding the entire workflow, the connections, rather than just mastering one specific isolated task.
Precisely. Collaborative planning, critical thinking, adaptability, these become paramount. These human strengths will complement the robot's precision and endurance. It's about leveraging the unique capabilities of both humans and machines to navigate that organized complexity of large projects Jane Jacobs wrote about. Rather than just fearing technology as some independent force with unanticipated but undesired consequences, as Samuel Foreman explored, the human role becomes strategic oversight, creative problem-solving, managing the dynamic interactions in a highly complex system. It's moving towards symbiosis, not just substitution.
The title of this deep dive, Teams of the Future, Humans and Robots Building Together, paints a really compelling picture. What does that ideal collaboration actually look like day to day on a job site? What's that dynamic?
In an ideal scenario, that collaborative job site is a truly symbiotic relationship, where the unique strengths of each participant, human and machine, are maximized and aligned. Humans provide the critical oversight, the strategic planning for complex sequences, the agile problem-solving for those inevitable, unexpected conditions.
The adaptability.
The adaptability, the nuanced decision-making, the creative adaptation, the overall quality control that robots currently lack. Robots, in turn, contribute their unparalleled precision, their speed, the enhanced safety by taking on hazardous tasks, the ability to work continuously without fatigue or error. And BIM, building information modeling, becomes that shared language. The knowledge resource, as the CMAA standards call it, facilitating seamless collaboration, allowing both human and machine to operate from a single, unified, highly detailed understanding of the project.
So it's really about harmonizing these very different strengths to achieve something better, safer, faster than either could do alone.
Absolutely. It's not just about what robots can do in isolation, but what humans and robots together can accomplish for the built environment. It means consciously designing this future, ensuring the social systems can co-evolve with the technical systems, as designing reality encourages. This integrated approach, maximizing and aligning strengths, is how we can potentially achieve unprecedented levels of productivity, safety, and innovation in construction, ultimately shaping a more resilient, sustainable, efficiently built world. Hashtag outro.
So today, we've really taken a deep dive into this fascinating and rapidly evolving world of robotics on the job site. We've moved past the sci-fi, hopefully, to see the tangible impact these machines are starting to have right now. We've explored how they're tackling everything from dangerous excavation and physically demanding work to incredibly precise bricklaying and automated drywall finishing, all orchestrated, really, by the intricate data held within building information modeling.
And we definitely haven't shied away from the real challenges. This significant capital cost, that huge hurdle, the inherently unstructured dynamic environment of a construction site, testing robotic capabilities constantly, and that critical question: how will this technology reshape the human workforce? The future really doesn't look like robots simply replacing people, but more like a dynamic evolution of roles, demanding new cognitive skills, fostering unprecedented levels of human-robot collaboration, creating an entirely new kind of construction professional. So as we envision this future, these intelligent machines assisting in constructing our world, maybe here's something to think about. If robots can now handle the dull, the dirty, and the dangerous, if they can consistently deliver precision and speed beyond human capacity, what new frontiers of architectural design, what breathtaking possibilities for creativity, what higher expressions of human ingenuity will be unlocked when the physical limits of building are no longer dictated solely by human hands? What will we dare to build next? And what greater purpose will our collective human and robotic efforts serve?